So today we are going to see memories. Okay, every time memories. This unit, what advantage you have is you can read it. You know what sort of question will be. There won't be any new question or problem. Problem will be there, but still you can easily do it. But all other queries, you can practice and you can write. So first we are going to start our university preparation from Unit 5 only. I'll give you notes in simple form for all the topics. And for IA2 also when we study this, I think one will be. So first one is memory. What is memory? So any memory is what? Storing. And in computer, memory is like a storage space in your computer where data is kept temporarily or permanently. So memory always need not be permanent. Sometimes it will be in our daily life also, whatever we see, whatever we experience, certain things are stored in our subconscious mind. So even whatever happened in your childhood days, you remember. But whatever happened yesterday, sometimes will be forgotten. So that is a temporary memory. Permanent memory. Like that in computer also we have something called as temporary memory and permanent memory. So memory is made up of registers. We have already seen a register. So a register is made up of what? Flip-flops. Each flip-flop can store a bit of information. What is a bit of information? 0 or 1. So registers are made up of flip-flops. Flip-flops can store 0 or 1. So this is what memory is made up of registers. Memory is made up of registers. Think of a memory as a big set of boxes. Each box is called as register or memory location. So each box has a unique address. So you can assume there are two boxes. You are storing, like how you are storing your clothes. So you will have some yellow color, green color, red color, blue color boxes. And in green color, you put all your goods. Yellow color, you put your food. Red color, you put your dress. And here, some toys or some play items developed. So this yellow is the address. Food is the data. Okay? So if I want food, which color I will go and search? Yellow color. So that is your address. So if you want some data, food is data, right? And if you want any data, there should be an address where it has to be stored or retrieved. So that is what will happen in the register and in the memory location. Memory location is nothing but address. How your post comes to your house, you have an address. In your house, you have a door number, you have a street number. That is how you are able to get the post or any delivery or anything. So there will be a location. In Google Maps also is shared your location. So there it will store all the data. And each box has its own address. Just like houses on the street have different house numbers, your memory location will have address. Inside each box you can store data. Whatever you want to store, you can store in that particular memory location. Storage elements. How we are storing and what is that called as cells. Cells. That is what is called as a storage element. Each box is made up of storage cells. So you have a box. So in that you have a lot of cells. This is your cell, this is your cell. Okay? So in each cell you can carry what? 0 or 1. 1, 0, 1, 1, 1, 0, 0, like that. Each cell will carry a bit of information. It can be either 0 or 1. If a register has 8 cells, it can store 1 byte. What is 1 byte? You need to remember all these things when you talk about the memory. So you have a box. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay? This is the register. In which and stored the bits. Each one is called as a cell. Okay? So all these things 8 bits called as a number. 1 byte is 8 bits. So how it is stored? Assume register like a box in which you will have small boxes, and in each box we are keeping something. Like that, in register is made up of storage cells. Each cell can hold 1 bit of information, either 0 or 1. If a register has 8 cells, that means you can store 8 bits. It is called as 1 byte. Okay, please remember this. Then capacity of memory, how much it can store. Total number of bits of bytes the memory can store is called as capacity of memory, how much it can store. Example, a memory with 1024 bytes can store up to 1024 into 8 bits. Because 1 byte is equal to 8. Right? 1 byte equal to 8 bits. So 1024 bytes can store 1024 into 8 bits. So that is the capacity of memory, how much it can store. Then writing and reading. So how we are writing and reading. Whatever we study, what we are doing, we are writing in our brain. Brain cells, there also we have cells. And when reading, what we are telling, we are asking the brain to give the data. Okay? So that is what happens here. Reading and writing. Writing and reading. Writing and reading. Writing is putting the data into the memory. Writing is what? Putting the data into the memory. Reading is what? Taking the data, getting the data out of the memory. Writing is writing inside, reading is taking outside the memory. So you can use a control signal. So you will be having read, write. If you want to read, this signal will go. If you want to write, this signal will go. And you can either read or write. So this is how we do it. Okay. So what you can see, this is a memory unit. 2 power k word can be stored. That means k address lines. If you have k address lines, you can store 2 power k words. 2 power k words. And these are the 2 signals. If you want to read, you will activate this signal. If you want to write, you will activate this signal. These are all the data lines. Okay? Data lines for writing as well as for reading. You can see this bidirectional. So see the arrow, both the sides. When you want to write, when you want to read, data will come here for writing, data will be read for reading. Okay? So this is how it works. This block diagram should remember both memories. Then words and bytes. A word is a group of bits that move together. A byte is 8 bits. Often a word is made up of multiple bytes. Example, 16-bit word. 16-bit word. You have 16 bits in that word. So 8-bit is called as one byte. So another 8-bit is called another byte. So totally you have 2 bytes. So in a 16-bit word you have 2 bytes. Okay. Then 32-bit word into 2, 4 bytes. So these words you should remember: bit, byte, word, read, write, memory, cell, register, location, address lines, data lines. All these terms you should remember for memory. Okay? Yes. How data goes in and out? How can we read? How can we read? So the memory connects the rest of the computer through data lines to send or receive data, address lines to tell in which memory the data is available. Okay? This is how you read and write. So when you want to read, what you will do? You will search for that address. You will search for that address, and whatever data is there in that address you will read. When you want to write, you will decide an address, go to that address and write your data. Write your data. Understood? When you are reading, you search already it is written. So you should search for that particular address only. And you can take the data. When you are writing, you will decide the address where you have to store. Then you will store the data. And control lines will help you to read or write. Which one you activate, that will be activated. When there are k address lines, we can access 2 power k memory words. For example, if k equal to 10, we can access 210. That is 1024 memory words. 2k is 1024. Then how many memory locations? If you have k address lines, you can access 2 power k memory locations. For example, k equal to 8. K equal to 10, then 2 power 10 memory locations will be 2 power 10 addresses will be. So you can store 2 power 10 1024 different words. So memory is nothing but storage with address. We store with address. Each memory location will hold data. It can be either in bit or byte. We use address lines to choose a location and data lines to send or receive data. Okay, in data lines we have data, in address lines we will point to a location. Control lines will manage whether you want to read or write, what operation you want to do, that will be there. So this is how it will be. Storage cells. So storage cells are there. These are our addresses. So in here write operation. So data 1003 is written there. Now this is the address. In that address the data is written. When you are reading operation, what it will do? It will search for that location and read that data. Okay, this is how it is. Then there are some 2 more questions in the university question. Bipolar RAM chip is arranged as 16 words. How many bits are stored in each chip? 1 word, 16 words. How many bits are stored? 1 word, 8 bits. So 16 into 8. That many bits will be stored. Then how many address bits are needed to operate 2k by 8 RAM? So here 2k by 8 you are calculating and we need one address line. 2 power 1 is 2 power 2k by 8. 2k address line means 2048 address locations. So 2048 is the answer. 2048 address locations are. Then how many locations are addressed using 18 address bits? Number of locations addressed. So again you have to calculate power. So these are some problems from your book. Next is classification of semiconductor memory. So what is memory calculation? Memory is where data is stored in computers. There are different types of memory depending upon how the data is stored. How we store the data. Some data, as I said, they are permanent, some are temporary. So how are we going to store the data? Whether the data stays after the power is off. When you switch off, data will go. Or sometimes, even if you switch off, again you can get the data. There are something called as volatile memory and non-volatile memory. And how data is accessed or erased. Sometimes during manufacture only they will write the data. Later we will not write the data. Sometimes it is programmable. Certain things are fixed, certain things are changing. You can program. Like that different types of memories are there. So that is what is the semiconductor memory. So main classification of memory is based on whether the data will be available when the power is off. So that is the classification. Volatile memory. What is meant by volatile memory? You need power to keep the data. Only if power is there, the data will be there. Data is lost when power is turned off. If you switch off or power goes off, the data is gone. Example, static RAM, dynamic RAM. Okay, static RAM, dynamic RAM are volatile memories because it will stay only when your power is on. When power goes off, it goes off. Then you come to non-volatile memory. Non-volatile memory means what? It will keep the data even if power goes off. It will keep the data even when the power goes off. This is why it is called as a permanent storage. These are temporary storages. Example, ROM, read-only memory, erasable programmable read-only memory, electrically erasable programmable read-only memory, and then programmable read-only memory. Like that, different types are. So whatever you write, you are using UV address. Using that we can write. So there are different types. The cost also will vary accordingly. So like this, you have the main classification. Then read and write memory RWM. You can both read and write it. It is also called RAM, random access memory, used for temporary storage when running programs. That means when power is there, you can read or write anything. Once the power goes off, it will go. Then static RAM, fast but expensive. So we have already seen whenever it is fast, definitely it will be costly. Keep data as long as the power is on. That means what? This is a volatile. Does not need any refreshing. The DRAM is lower and cheaper than the RAM. Stores data as charge in the capacitor. It stores in the form of charge in the capacitor. Needs to be refreshed often to keep the data. Charge and discharge will happen because capacitor is there. Like that, this is what is the difference between static RAM and dynamic RAM. Then read-only memory. In that you can only read. Already in the manufacturing time only they will write everything. You can only read, you cannot write anything. Data is written once and cannot be changed. This is a normal Normal ROM, normal ROM is read-only memory and used to store fixed data like routing, system forward. When you start the computer, there should be some routing software that will be written in ROM. Then different types of ROM. These are all important questions. Definitely they will ask you. ROM is the data fixed during manufacturing. ROM is read-only memory, so you can only read, remember like that. So when they will write, when you can only read means they have to write during manufacturing. When they are manufacturing the ICs, they will do. Then programmable read-only memory means what? You can program it once after making. They are manufacturing, if they are writing something and you need to do, you can program only once. Or they will give you a blank ROM, bring it to your company and you program once. Only once you can program. An erasable programmable read-only memory, that means what? It can be erased using any line and then it can be reused as many times as you want. They will put up, there will be an IC in a setup will be on top we have UniLine. And here you raise the IC ROM, that is EPROM. I have worked with all these things. I have written data. I told you I worked for the barcode reader project. So we will keep changing the program. So we keep that inside here it can be utilized. So I can erase. There will be a switch where I can press, it will erase. Then I will make a program. Then electrically erasable, programmable, read-only memory. This is UV light. There is another way also you can use it electrically and it can be used. Other classifications are LIFO and FIFO. That is first in, first out. Like a queue. Like a queue, it will be the data will be. After this comes, this will come, then it will come. First in, first out, like a queue. The first data you think comes first. So if this is your first data, this will come first. This will come first. This is the second data, this will come second. Like that. LIFO is last in, first out. That is, this will come first. This will come first. Last in, first out. Then based on technology, you have classifications of memory. That is bipolar memory. When we use bipolar, what is bipolar? Both the directions you have to off. So bipolar. Made using bipolar transistors faster, but uses more power and more expensive. Okay. And mass metal oxide semiconductor memory uses mass transistor slower but less power. It consumes less power. In CMOS also we have studied that it consumes less power. When it consumes less power, slower, so it is cheaper. Okay? And it is very common. It will be available everywhere. So this is what is the summary table. So this type of tables will help you to remember and write instead of big theories. So static RAM, dynamic RAM, read-only memory, programmable read-only memory. Static RAM is volatile. That means it will not stay when the power goes off. Whereas ROM is permanent. PROM is also permanent. Even if the power goes off, the data will not go. Read and write. In SRAM you can read and write. In dynamic RAM you can read and write. These are all happening when you go to the computer lab and writing a program and it's easy. So temporarily you can read and write. When you switch off, it will go. If you don't save, it will go. But here in read-only memory, you cannot read actually. You can only read, you cannot write now. Only read. You cannot write. Then special feature, this is fast. Because in dynamic RAM you have capacitors, it will charge and discharge. So you need to refresh. And when the data is set during manufacture, PROM is what? You can program. One time you can program at your company. So this is classification. Then EPROM. EPROM is again not volatile. It will stay. So you can only read. So this is erasable and this is erasable with unit. So this is all for your benefit. Next is read-only memory. You cannot write or change data in long after it is made. It is permanent. Okay, read-only memory, the company itself will not change. And it is non-volatile. That means even if power goes off, the data will stay. Used to store important data which you don't want to change, like booting your system and all. Sometimes permanent. You don't have to change only. Those things will be stored in this ROMs. Program that tells the computer what to do first. Startup instruction. When you press the power in the CPU, some booting takes place. That is regular every day, every time. So that type of programs will be stored. Fixed data. So how do you access this ROM? Even though its memory is called read-only memory, it's still a random access memory. This means you can access any piece of data in RAM by its address quickly and directly. Immediately you can go and fetch data. So how does it work? ROM cell has main parts, two main parts. Transistor acts like a switch controlled by a word line. And this connects the transistor to ground or using open. When the word line is on, the switch P is closed. I'll show you this later. This is the one. So when it is open, whatever data stored is VCC 1. When it is open, what happens? There it is connected to VCC. When it is closed, where it is connected to ground. So it is that switch when you only 1 and 0 you can write. So the switch is open, it is connected to VCC, so 1. When it is closed, it is connected to ground, so it googles for 0. Like that, okay. About read-only memories. In read-only memory cannot write data after manufacturing. Store fixed instructions and data, and it's also called as a random access memory. You can access the data from different locations. A non-volatile data means what? You can retain the data even after the power goes off. When ROM cell output bit is 0 if the switch is closed, and 1 when it is open. How it works? This is also an important question. I will ask you to explain the ROM cell. Bit line is connected by a resistor to power supply since the circuit reads the output. Transistor P controlled by the word line and switch P connects transistor to ground or output. The data storage, when it is stored during manufacturing. When open or close switches beside the bit 0 or 1. When you open, it is 1, when you close, it is 0. Then masked row, it is data fixed during manufacturing, cannot be changed. There is something called as masked row, you cannot change. Then PROM, programmable read-only memory, programmable once after manufacturing. Okay, PROM is once you can program. It cannot be erased. There is no P in front of us. It's only PROM. If you have EP, then erasable program. Here you have EPROM. You have this additionally E and P. What does it mean? Erasable, programmable, read-only memory. That means you can erase and write the data. You can erase the data with UV light and can be reprogrammed as we learn the programs you want. Then EEPROM is what? Electrically erasable, programmable, read-only memory. So what you use to erase is the difference between these two. Then programmable read-only memory. This is your programmable read-only memory. So this is a type of memory that user can program once after it is made. Programmable read-only memory is what? Manufacturer is given you the IC, chip. You can program. How many times you can program? Only once. So how it is programmed? Each memory cell has tiny fuse. Each memory will have a tiny fuse like a small wire. Okay? If the fuse is intact, then it stores 1. It's like a fuse. If it is connected, it is 1. If it is blocked, it is 0. Programming process. To program and program PROM, a special device called PROM programmer. PROM programmer. You have to buy that. The company should buy that. And send a strong current pulse to blow the fuses. So initially, all are connected. I want 100 to store. What will I do? I have to send strong current to all these lines and I should blow which I don't want. When I blow the fuse, I'll get 1, 0, 0. So I am doing, once I finish doing that, I can't change. Only PROM, only once I can blow. So what happens after programming? Once the fuses are blown, the data is permanently stored. You cannot change the data afterwards. That is why the PROM is called as one-time programmable memory. See, this type of questions, even if we ask PROM or one-time programmable memory, you should know both are same. Both are same. Here it will twist. You know the answer, but you don't know the name. So here you have to be careful. One-time programmable memory is nothing but PROM. When PROM is used, when you want to store fixed data that does not change, but you want the option to program it yourself after manufacturing. ROM is programmed during manufacturing. PROM is programmed by you. In your company, in your place you can program. You need not tell the company about your program. For ROM, you have to give the data to the company, to the manufacturer. He will know. So sometimes some secret designs will be there. You cannot give it to the manufacturer because that will be used by some other company. He will sell the data. So what he will buy, PROMs he will buy. You just give me, I will program. Okay? So that is why it is better. So PROM is used when you want to store the fixed data that does not change. So here you have a fuse, right? This type of, this is one PROM cell. Like this you will have number of cells. So this is the fuse. Initially they will connect and give. When you don't want, you will blow that fuse. How many times you can do that? Only one. So this is how the fuses work. If you don't want only, you can, I don't want. That means what will happen? What will be the value there? 0. 1, 1, 0. 1, 1, 1. 1, 1, 0. 1, 1, 1, 1. 1, 1, 1, 1, 0, 1, 1. 1, 0, 1, 1, 1, 1, 1. This is how I am programming in my company. Wherever you don't want the fuse, remove the fuse. That will become 0. Because you can store only ones and zeros. Okay? Then coming to EPROM, erasable, programmable, read-only memory. See that other there will be a window here. There will be a glass type of window. So when the light is focused for a few minutes or seconds, we are looking, it will erase everything. It will erase everything. A type of memory you can program and later erase using ultraviolet rays. Any number of times you can erase and write the data. When we do R&D, we do this. Research, we don't know what is the final answer. So we have to try again and again and again. So we use this erasable program or read-only memory. Data is stored using electrical charges. And how it works? All bits. Huh? Name is relevant. All bits are 1 after erasing. How it works? All bits are 1 after erasing. After doing this, all the bits will be made to 1. Like how we had the fuses in that. Like everything will be 1. You program zeros. You program zeros using a special device called as EPROM programmer. Okay? So EPROM, we can erase and program. For erasing, we use ultraviolet. For programming, I use an EPROM programmer. What is a device? It will be a device where you put the IC inside the IC. Initially, all the bits will be 1. Programming means what I should do. Wherever I want 0, I have to make that 0. That is my program. Very simple. Understand the concept, you can write everything. Okay? The programmer applies address and data. Where you have to store. I said no, in any memory, you need to have an address where you have to store the data. Then erase it. Expose the chip to UV light. How many minutes they are asking you to expose? Into 20 minutes, it will be kept under the ultraviolet rays. Through a quartz window. That is a material. Quartz is a material. That is a window means this is an IC in between. This is your quartz window. So the light will go through. UV light will pass and erase it. So reusability can be reprogrammed multiple times. How many times you want to cover? On R&D, we will use EPROM. Okay? So ideal for product development, experiments and college labs. Within it is cost will be less, no? Any number of times you can erase it. Then EPROM is electrically erasable. There we use UV light. Here we are using an electricity to erase the data. So a type of memory similar to EPROM, but we are using the electricity and not the UV light. Data is stored as charge. Charge means 1, no charge means 0. On a thin insulated gate. The electrical erasing uses a low voltage of 20 to 25 volts. The insulating layer is very thin, allowing easy movement of charges. So through the electricity we are erasing. And again using a programmer, we are programming. Okay? So you can erase and reprogram, and also it has a chip erase mode that clears everything. There is also a mode where if you want to erase, delete everything, control alt del, what happens? It will not even go to, sometimes it will not even go to the recycling bin. Isn't it like that? You will be erasing completely also, not one by one. Select all, delete. Like that. Then advantages is faster. This is faster than EPROM. Electrically erasable, programmable memory memory is faster than EPROM and can be reprogrammed in circuit. No need to remove the circuit. Even when it is in the circuit connected, the circuit also you can do it. Offers flexibility of frequent updates. Whereas EPROM, I have to remove the chip from the circuit and keep it inside the UV. Are you able to understand the difference? So this is also because of all those facilities, what are considered expensive. When you want more facility, it will be expensive. Lower storage density compared to other ROM types. So this is what is the difference between these two. Erasing method. In EPROM, we are using UV light. Here electrical signal. Can erase partially, no full erase only. Here you can individually erase. If you want full also you can do it, but if you want only one portion also do that. Can you reprogram? Yes. After erasing you can reprogram. I don't have to remove that from the circuit. I can keep it in the circuit and do it. And speed is slow, fast. Cost is lower, higher. The use cases development and labs, that means R&D, research. Flexible updates. When you want to change some updates, you can use them because it is possible. Another one, EAP now. This is our EP now. E now. Now what is this? EAP now. What is that? Electrically alterable programmable memory. So it is a non-volatile memory, which means the data will be there even if the power goes off. And unlike regular PLOG, it can be programmed without removing it from the circuit board. Then advantages: selective programming and erasing. Whichever portion you want. If you have some oil falls in my side, whatever, I don't want to wash it. Then you use only that area and I will wash. Like that. Wherever you want, you can change that particular area. Fast operation. Average time is only 5 to 10 milliseconds. And then programming time is also very, very fast in microseconds. Disadvantages again. There are advantages, disadvantages will be there. Expensive, limited availability, not widely used. Not widely used. But that is this one. Next is random access memory. This is another memory. It's a volatile. Volatile means when power goes off, data goes up. So you have static RAM, dynamic RAM. So static RAM is a type of RAM that remembers the data as long as the power is on. And it does not need refreshing. No refreshing is required. It is not static because the data stays stable without any special character. When it is static, stable we call it as static. When it is changing, we call it as dynamic. So this is how the SRAM is celebrated in work. So these things we will see in the next class. SRAM is the dynamic practice. Okay? Thank you.